Welcome to 4.4, more on graphing linear equations. Now, first thing I'm going to do is talk about x and y intercepts. We've talked about them, I believe, a little bit in the past, but I want to put a more definite point on this. Now, if this is some plane, if we have a line that goes like this, we know that we're going to have an x-intercept, which is right here. It's, in fact, where the graph crosses the x-axis. And we're going to have a y-intercept here, and it's where the graph crosses the y-axis. So recall that's the x-axis, and this is the y-axis. Now, every x-axis, or every x-intercept, like if we had another line that did this, these two x-intercepts have something in common, this one and this one right here, and that's that the y value equals 0, because we haven't gone up and we haven't gone down, so these are going to be something, comma, 0. We know the y is 0. That right there is the ordered pair something, comma, 0. So because the x-intercepts is where the graph crosses the x-axis, and it's where y equals 0, we always have these ordered pairs a, comma, 0. And that tells us how we actually find the x-intercepts. To find an x-intercept, set y equals 0, then solve for x. So we can make the little t table, little x, y, plug y in for 0 and for y, solve for x, get some coordinate and plug. Now, with the y-intercepts, they also have something in common too. Like this y-intercept right here and this y-intercept right here have something in common, and it's that x equals 0, because we haven't gone to the right, we haven't gone to the left. So these are always 0, comma, some number, and that's exactly what it says down here. Now, because it's where x equals 0, if we want to find the y-intercept, how we do that is we set x equal to 0 and then solve for y. Okay? So, essentially, that is how you solve for x and y-intercepts. So, we're going to find some x and y-intercepts and then graph some lines using it. And the x and y-intercepts are a really good thing to find out, because if you know what the intercepts are, that gives you 2 points. The 2 points can uniquely determine the line. So, okay, so let's take a look at this here. Now, make a little xy table. Now we're going to first find the x-intercept, so we're going to plug 0 in for y, and we're going to plug it into this equation here. So plugging that in, we have 6x minus 3 equals 9 times 0. So we're plugging 0 in for y. 0 times y is 0, so we get 6x minus 3 equals 0. Add 3 to both sides. We get 6x equals 3. Divide by 6. We get x equals 3/6, or 1/2. So we know that 1/2, or 0.5 comma 0, is the x-intercept for this graph, so we can plot that. That's right there. So I'll say 0.5 comma 0. Now, we found the x-intercept. Now, if we find another point, like the y-intercept, we can graph it. So now what I'll do is I'll put 0 in for x, and that's how we do that. So plugging 0 in here, 6 times 0 minus 3 equals 9. So those cancel off, and we get negative 3 equals, and there's a y, 9y, divide both sides by 9, and we get y equals negative 1/3. Okay, so when x is 0, y equals negative 1/3. We can plot that point right there. So we have 0, comma, negative 1/3. We have our x-intercept and y-intercept, which are 2 points, and we can draw the graph of that line. Okay? So moving on to this next one here, we're going to go ahead and find the intercepts here. We're going to find the intercepts over here, and we're going to do that by plugging zeros in. So once again, we have our x, we have our y. If we're finding the x-intercept, we set y equal to 0. So plugging that in over here, 2x plus 5 times 0 equals 10. This cancels, so we have 2x equals 10. Divide by 2, x equals 5. So, when y equals 0, x equals 5, that gives us 1, 2, 3, this ordered pair right there, 5, 0. So we have 1 point. To find the second point, we can find the y-intercept, so we're plugging 0 in for x. So look back to this original equation here, plugging 0 in for the x. 2 times 0 plus 5y equals 10. Well, 2 times 0 is 0, so we have 5y equals 10. Divide both sides by 5. We get y equals 2. So we have, when x equals 0, y equals 2. So we can plot that point right there. 0, comma 2. 2 points uniquely determine a line, so then to find the graph, just draw the line that goes through them. So that's kind of what we're doing here. So we'll take a look at these next two. So x, y, finding the x-intercept, setting y equals 0. So 6x minus 2 times 0 equals 12. Those cancel, so we get 6x equals 12. Divide by 6. X equals 2. So 2 comma 0. Plot that point. Now we want to find the y-intercept, so we're plugging 0 in for x. So right from up there we have 6 times 0 minus 2y equals 12. 6 times 0 is 0, so negative 2y equals 12, divided by negative 2. And we get y equals negative 6. So when x equals 0, y equals negative 6. Plot this point. 1, 2, 3, 4, 5, 6. 0, negative 6. Draw the line. Whoops, and we missed. So we can try that one more time. And woo! Well, you know what I'm saying. It's close enough. So we're going through those points. Now the last one we're going to do is this one, and go ahead and find the x and y intercepts. So finding the x-intercept, we plug 0 in for y. When we plug 0 in for y, we have 0 minus 3x equals 0. So 0 minus 3x is just negative 3x, so this goes away. Divide by negative 3. And we get x equals 0. So notice, when y is 0, x is 0. So this really tells us that the origin is a point on a graph. So because we have that, it's both an x and a y-intercept. We found the x-intercept, but it turned out to be the y-intercept. So we need another point to plot this line. And since we already have the x and y-intercept, we can pick another value. We just pick any value we want and plug it in for either variable. I'm going to pick 1 and plug it in for x because 1's a small number, easy to work with. And notice when I plug it in up here, y minus 3 times 1 equals 0. So this is y minus 3 equals 0. Add 3. And we get y equals 3. So when x equals 1, y equals 3. So we can plot that point, 1, 3. So we have 1, 3, we have 0, 0, 2 points uniquely determine the line, and that's what's going on with that right there. So finally, there's a couple different things we want to take a look at here. Now, we want to look at vertical and horizontal lines. So right here, if we have a horizontal line is something that looks about like this. Now, every horizontal line has a y-intercept. Like every line that's horizontal is going to cross the y-intercept somewhere, so they define that to be the point right there. So this could be like the line y equals 7 as long as this is the y-intercept 0, 7. Okay, so that's the graph of a horizontal line is y equals. Now, if we think about the slope of a horizontal line, rise over run, you know, it's like how much do we rise as we go across this line? Well, 0. How much do we run? Sum. 0 divided by any number is 0. So the slope of a horizontal line, m equals 0. That is, we have no rise, we do have run, and that's that. Now, a vertical line, on the other hand, is like this. And it's going to have the equation x equals, and every vertical line has an x-intercept, because you can't have a vertical line that doesn't cross the x-axis. So let's say this crosses at 5, 0. The equation of this would be x equals 5. And really, every ordered pair on here, like that's probably, I don't know, 5, negative 3. And up here, that would be like 5, negative 2. And then there's one up here, which would be 5, 7. But all of the x coordinates are 5 of all of the ordered pairs on this line. That's why the equation is x equals 5. Similar thing with this horizontal line, because all of the y values, something, 7, over here, something, 7, all the y's are 7, that's why we get the equations y equals 7. Now, if we think about what the slope of a vertical line is, with rise over run, well, it's definitely rising, so it rises some. And it's definitely running 0, So any number divided by 0 that's not 0 is undefined. So what that tells us is the slope of a vertical line is undefined. So anytime we see the slope is undefined, we know that's a vertical line. Anytime we have a slope of 0, we know that's a horizontal line. Alright, see you for the next part.